Okay, good morning. Here's your starter. Find the obtuse value for each of the angles, should be an S, marked theta. Okay, so we need the sine rule, but I want the obtuse angle. Okay, so not necessarily the principal value. So bring in the work you did last week. Okay, so if you pause that, have a go. I'll go over the answers very soon. Okay, so it's the sine rule. So we've got sine C is equal, right, I'm going to do just do the multiplying. Obviously it's sine C divided by 9, but I've already done the rearranging. Sine of 15 over 2.5. Obviously you need to do the inverse sine, tap that into your calculator, and you get the answer of 68.7 degrees. Now obviously that is not obtuse, it's not bigger than 90, so because of your work we did last week, remember we've got our principal value here, we need this value here, the obtuse one, so it's 180, take away 68.7, so obtuse C is 111.3. It's called the ambiguous case of the sine rule. Okay, you won't be asked for the ambiguous case, but it will say find the obtuse value. Okay, so we need to do the same for all of them. So now we've got sine of B, rearrange it, so 14 times sine of 34 over 8, inverse sine, tap that into your calculator, and you get 78.1 degrees, but again, obviously not obtuse, so our obtuse B is 180 minus the 78.1, it's not very helpful, calculator error, 101.9 degrees, and then same with this one, sine of theta is equal to 7 times sine 40 over 6 gives us 48.6 degrees, but again not obtuse, so we need 180, take away that, which gives us 131.4, which actually would make the other angle very, very small and make that one about 9 degrees, but it would still work. You could still draw the triangle two different ways. Okay, so just pulling in what we learned last week with our sine rule, just to work out if we're asked for an obtuse angle. Okay, now what we're doing today is exact trig values. Now they do come up on the non-calculator paper, but they're also really, really useful to know and learn for when you go on to do A-level. Hopefully you're going to do A-level maths. So we've got two triangles there. If you could fill in the dotted lines with the angles and the side lengths, that would be a really good starting point. So copy the diagrams, obviously pause the video, fill in those gaps. Okay, so equilateral triangle, they're all 2. So actually, it's equilateral triangle. That must be 60 degrees. That must be 30 degrees. Let's have a think. Well, if that's 2 and we've cut it in half, that's going to be 1. Now this length here, we need to do a bit of Pythagoras. So we need to do the longest side, take away the shortest side. Obviously square them, which is going to be root 3. Okay, so we're going to be looking at sine, cosine, tan of 60-degree angles and 30-degree angles, and that triangle is going to help us with that. Whereas the other triangle, this one here, is an isosceles triangle, sides the same length. It's actually a right angle isosceles, so these are both 45 degrees. And now we can work out the hypotenuse, again, Pythagoras. 1 squared, we're finding the longest side, hypotenuse, so we add them, 1 squared plus 1 squared, square root of 2. Okay, So we've now completed these triangles. What we actually have to do, or the ones we need to remember, are the exact values for 30, 45, 60, and actually 0 and 90 as well. But let's concentrate on these for now. We looked at 0 and 90, and you can get those off your graph fairly easily from last week. So let's do the 45 degree one first. So if we wanted sine of 45, got our angle 45, we know the sine of 45 is opposite over hypotenuse. So 1 over root 2. Might be that you rationalise the denominator, get root 2 over 2. Okay, but they are the same value. Same with cosine of 45. This time we want adjacent and the hypotenuse, sorry. And then tan of 45. Well, hopefully you realise that's a nice easy one to remember, is 1, because it's 1 divided by 1. So let's transfer those into our table. So we've got 1 over root 2, 1 over root 2, and 1. But we also wrote these with the denominator rationalised. Okay, let's go back to the other triangle and see if we can complete the other columns. Actually, you could do that. So I've done the tan of 45, I've done all of the 45s. Pause the video, see if you can do 30 and 60. Okay, so let's go. Let's do 60 first. So sine of 60. Sine is opposite over hypotenuse, root 3 over 2. Because we've got these values, it's just a matter of plugging them in. Cosine of 60 is adjacent over hypotenuse, so 1 over 2. Tan of 60 is opposite over adjacent. Sorry, brain went dead there. Right, okay, so we can pop those values in our table. Root 3 over 2. We said that was a half, and that was root 3. So now let's go back and do our 30, or double check that you got the 30 right. You may have already done these. So sine of 30, opposite is a half. Sorry, opposite over hypotenuse. Cosine of 30, adjacent over hypotenuse. And then we've got tan of 30, which is opposite over adjacent. So 1 over root 3, or root 3 over 3. Okay, so let's put those in our table. So we had root 3 over 3, but actually it was 1 over root 3. We then had, that was root 3 over 2, and this was a half. Okay, so now we've got our values. You do need to learn these. Okay, you need to be able to get them off the top of your head, or alternatively, remember these triangles. Okay, and I know a lot of sixth formers used to remember these triangles. Okay, so what's it going to look like in your exam? Well, in your exam, it could potentially look like, so 2 different types of questions. Bear in mind these are non-calculator, so don't go reaching for your calculator. But we need to calculate the length AC. Okay, so we want the hypotenuse, we've got the opposite. So it's basically going to be sine of 30 is equal to opposite over hypotenuse. Okay, well, we're not allowed to use our calculator, so let's have a think. What did sine of 30? Well, sine of 30 is a half. So AC is equal to 20 divided by half. Sine 30, we just looked it up. Hopefully we might even better remember it. 20 divided by half. Well, how many halves go into 20? 40. So it's 40 centimetres. So we can actually now do trigonometry without a calculator. you might also get a question like this. These are becoming a bit more common in their being asked more often, but it looks complicated, but it's not, because we know that tan of 60, well, we might know that tan of 60 is root 3. Obviously you won't have the table to help you, but let's fill it in. Plus 3 tan of 30, well, tan of 30, we can either use 1 over root 3 or root 3 over 3. Well, because of the form that it's actually asking for, I'm going to go with root 3 over 3 because there's nothing divided here. So let's stick with that. Well, 6 root 3 can be written as 6 root 3. Because we're multiplying by 3 and dividing by 3, that just gives us 1 root 3. Which therefore, when we simplify it together, this is where being good at surds actually comes into its own, really. 6 root 3 plus root 3 gives you 7 root 3. So A is 7, B is 3. And that's the type of question they're likely to ask you. Okay, so as I say, this is quite a sort of a topic that comes up, non-calculator paper or assessment. And yeah, it's towards the end generally, but you know, if you can remember this table or come up with a way of remembering it, you will be absolutely fine with this topic. So there I have given you a couple of slides with questions on. So obviously you're meant to be doing it without a calculator. I've got no way of really checking that other than how, if you give me your answer in a load of decimals, I know you've probably used your calculator. So have a go at them, see how you get on. Obviously once you've done them, you can check your answer with your calculator and make sure you're right. But they also put a list of those questions that we've just done there to work through there. It's good practice sort of simplifying and manipulating your surds anyway. I suppose the only thing to note there, sine squared 30 is actually sine 30 squared. So if you get the sine 30, you can just square it. Okay, which is obviously just times in by itself. So have a go at those, see how you get on. Please submit your work on Show My Homework so I can see how you've got on. Yeah, okay. And then tomorrow I think we've got our live session, and I think we'll start vectors on Wednesday. So that's pretty much the week. Okay, but do keep posting in Show My Homework so I can see how you're getting on, please.